Hi everyone, today I'm going to go over how to convert units using dimensional analysis. This is a skill that we're going to use all year, and right now it might seem like doing these steps is kind of silly and a waste of time because these conversions might be relatively easy, but I promise later on in the school year when we will use this process with actual chemistry stuff, and if you learn how to convert units this way, it makes your life a million times easier in the long run. So even if you think this way, setting it up is dumb, I need you to go with it. Trust me. So before we get started with conversions, there are three three conversions that you need to know. You need to just flat out memorize. 1 kilometer is 1,000 meters. 1 meter is 100 centimeters, and 1 meter is 1,000 millimeters. These are metric measurement units. What's nice about the metric system compared to the normal US system is that whether it's gram, liter, or meter, the conversions are the same. So 1 kilometer is 1,000 meters. You could also say that 1 kilogram equals 1,000 grams. Just change the word meter right here to gram or to liter, and then it's true on this side. So 1 kiloliter equals 1,000 liters. So metric is pretty nice. The conversions are true whether it's meter, gram, or liter. You just have to change the word. So 1 liter is how many centiliters? That would be 100. 1 liter equals 100 centiliters, just like 1 meter equals 100 centimeters, or 1 gram equals 100 centigrams. It's all the same conversion, except for it's just a different letter, liter, meter, gram. Okay, and so how to do dimensional analysis or how to convert your units. Before we get started, I just need you to know in chemistry we use measured numbers, which means there are actual numbers and there are units. So we don't ever just say it's 100. It's 100 degrees Celsius, 50 meters, 0.1 of a second, 1,000 kilograms, and the unit is a part of the number. But oftentimes we need to change our unit. So we're given something in seconds, we need it in hours, meters, change it to centimeters, etc. And so this process, dimensional analysis, is just how we convert units. And when we convert units, we're not changing the value of the number. If you have a $100 bill, or you can have 100 $1 bills, guess what? It's still 100 bucks. And so when I change my units, like from centimeters to meters, the value is still the same, even though the unit is something different and the number is something different. The actual value of it doesn't change, just like having a $100 bill and 100 $1 bills has the same value. And so our steps for dimensional analysis: identify what unit we're starting with, and then look at the unit that we're ending with. And then you'll identify an equivalence, which is a conversion factor that will help you make that conversion, like 1 meter is 1,000 millimeters. That's an equivalence. Oops, I meant to erase. And then we're going to do the math. You multiply numbers across the top, divide it by what's at the bottom. That will make more sense in a minute. And then answer with the correct number of significant figures. So number 1, and 25.4 milliliters. To change it to liters. So I'm starting with milliliters and I want my unit to become liter. The equivalence or the conversion factor between milliliter and liter is there are 1,000 milliliters in 1 liter. And so to actually do the dimensional analysis, we're going to take the number that was given, 25.4, and we start with that many milliliters. And we're going to set up multiplication with a little fraction. And this fraction is where we're going to use this equivalence. Now, we can't just throw the numbers wherever we want. Do you remember how I said units are a part of the number in chemistry? So let's just pretend that I put 1,000 milliliters here and 1 liter here. So units get multiplied with the actual number. So let's say you did that. Now you have milliliters times milliliter. So your unit would be milliliters squared and then divided by liter. Is this the unit that the problem asked for? No, it asked for just liter. So that was not set up correctly. So I'm going to erase that. And instead, we're going to put the 1,000 milliliters at the bottom and 1 liter at the top, because now milliliters and milliliters, you've got one up top, one at the bottom, they cancel out. It's like that unit wasn't ever there, which is what we wanted, because we don't want milliliter to be in our unit. We want our unit to be liter, and liter doesn't cancel out with anything. So that unit is left over. And then to do the actual math in your calculator, you would type in open parentheses 25.4 times 1, close your parentheses, divided by 1,000. So we multiply the numbers across the top and divide it by what's at the bottom. And when you do that, you should get, and I'm going to have to erase this, 0.0254 liters would be our answer. So that's the first example. We're going to do quite a few more so that you can feel comfortable setting up your units. Don't worry about that. So we're going to convert 23.9 kilometers to meters. I'm going to start with kilometer and I want to change it to meter. So the conversion factor between those are 1 kilometer equals 1,000 meters. And then to set up our dimensional analysis, we're starting with that many kilometers. So 23.9 km times, and I want my units to cancel, my kilometer unit to cancel. So I'm going to put 1 kilometer at the bottom and 1,000 meters up top. Now my kilometer units cancel out, and if you want to X them out, you can, and we're left with the unit meter. And then that's the unit that we wanted. So mathematically, what we would type in the calculator, 23.9 times 1,000, and then divided by 1. And you don't have to type divided by 1, but you can if you want. And that is 23,900 meters. Also, as you do these problems, especially right now, some common sense should come into play. You should know a kilometer is really big. So if I have 23 kilometers and I'm changing it to meters, that should be a lot of meters. And looking at our number, it is. Let's say you got something like 23 kilometers was 0.239 meters. Something in your brain should be like, that doesn't seem right at all, because it's not. A kilometer is really big, a meter is really small. So you should have a lot of meters for every kilometer. Okay, now we're going to do one that's a little more challenging. 22.1 centigrams to kilograms. So centigram to kilogram. Okay, thinking about our conversions. I know centigram is the same thing as a centimeter, but it's gram. So I know that 100 centigrams equals 1 gram. And then about kilograms, I know 1 kilogram equals 1,000 grams. And so I'm going to have to use 2 conversions to change this number. Okay. So start with the number in the problem, 22.1 centigrams times, I'm going to use this conversion first to get rid of my centigram unit. So centigram will go at the bottom, and then 1 gram up top. And then we're just going to set up another one. Now I've gotten rid of the unit centigram, and I've got gram. So with this conversion, I want my answer to be kilogram. So I need to get rid of that gram unit. So 1,000 grams will go at the bottom and 1 kilogram up top. And then that gram unit has canceled out, and the only unit we have left is kilogram. Now to type this one in, because it's a multi-step problem, this is exactly how I would type it in. Open parentheses, 22.1 times 1 times 1. Close, divided by, open your parentheses again, 100 times 1,000. And why I'm doing it like that is you have to multiply all of the top together, and then you have to multiply everything at the bottom together, and then you divide. And so using these parentheses will allow it to go in the correct order of operations. If you don't use parentheses, and let's say you typed in 22.1 divided by 100 times 1,000, your order of operations will be off, and it will give you the wrong answer, which that'll be really frustrating when you keep getting points knocked off just because you're typing something in the calculator wrong. So everything at the top goes together, and then everything at the bottom goes together. And use parentheses around them. Oh, and then when I type that in, we should probably type that in, get the answer. When I type that in, I'm going to erase this. My answer is 0.00022, and the unit was kilogram. And then hopefully in your brain, you stop and think, does that make sense? Well, if I have 22 centigrams, like a centimeter, that's not a lot of centimeters. 1 kilometer is really big. It's 1 kilogram is 1,000 grams. And then I don't even have 1 gram because I only have 22 centigrams. So it should be a really small number, and it is. So that makes sense. My answer is probably right. And then we're going to do one more. So how many seconds are in 14 days? So let's think about what we know about a day. Well, let's start it up. 14 days. Well, I know one day has 24 hours. So that will get rid of my day unit. I'm not at seconds yet, but getting there. Okay, now I have hour. Well, what do I know about an hour? 1 hour is 60 minutes. So now my hour unit is canceled out. Now I have minute. I want it to be seconds. So one more. 1 minute is 60 seconds. Boom, boom. And then now let's double check. Our units canceled, days, day canceled, hours canceled, minutes canceled. I'm left with seconds, which is what I wanted. So to type this in, 14 times 24 times 60 times 60. And then there's only 1 at the bottom. So if you want to type in your calculator divided by 1, you can, but you don't have to. And that final answer is 1,209,600, or 1,209,600 seconds. And this is how we do dimensional analysis.